me make life harder for you.
Yeah.
Okay, you are describing here two revolutions. One of them I always thought it was counter-revolutionary, and the other revolutionary, and let's see how they can fit together. On the one hand, now you say after 120 years of quantum mechanics, every time that you think that the particle went through the two slits, or 17 slits, or thousands of slits, it actually goes through only one slit. Let me confess that I never felt comfortable with that, because I thought that was counter-revolutionary. The revolution was in the Schrödinger picture that tells you that it's absolutely a wave and then it's absolutely a particle, and there is some tension between them from which quantum mechanics keeps developing. And you say, no. In reality, it goes only through one slit. I even remember a paper that you wrote with Jeff and the guys, making sense of the two-slit experiment. So you went against Feynman, who said never think about it because you will fall into a hole and you will never emerge from it, and you plunge into the hole. And you actually say, look, Feynman, I can tell you, it went through one slit. And this is something which was always harder for me.
Now, but let me hold your horses, because not only I tell it, I can prove it by experiment. The idea is, I send the particle in what people call wave, so supposing it goes through both slits. Then, instead of measuring the interference by making a strong experiment to see where the particle is, I do what I call weak measurements that only measure very weakly where the particle is. Instead of the photographic plate, after the two slits, I make a very weak measurement where the particle is, and then I make a strong measurement that shows me through which slit the particle went.
Sure. So let me only explain. You are now actually outsmarting Heisenberg, because Heisenberg's uncertainty principle says there are two questions that you can ask. Either which path, and you can find out that it went for this slit or the other slit, but you will lose interference. Or you can see interference provided that you never tried to find out which path it took. And now you say, yes, just watch, I can do that. I can get information about the which path and tell you that it went only through one path, and I did not destroy interference. And this is how you invented weak measurement. Right. You believe that you can eat the cake and still leave it uneaten.
No, I'm just saying that really the particle has two information. The one information is through which slit it went, and the other information is what I call the modular momentum that tells it where should it appear later in the photographic plate. And these two informations are at the present, because one information I found in the past and another information I found in the future. So the new way that I think about quantum mechanics is the fact that I can have two information rather than the one that everybody thought up to now.
Okay.
And I can check both information only by weak measurement, only when I have an ensemble of particles that are having the same boundary conditions.
Okay. Let me just explain to the viewers that every time that you do this gesture, you are saying something which is the most revolutionary possible. You are talking about two measurements in time, one in the past, one in the future. These are the two measurements that we are making on the particle. And what you say is that the evolution in between is affected both by the past and the future.
Yeah.
Nothing like that we know in our ordinary life. We are now affected by our morning, whatever we ate at breakfast and so on. The evening is still unknown, it's still in the future. It would be the most ridiculous thing to say that our behavior now is affected by both events in the morning and at evening, because it's now noon. So actually, this is what you say explains some of the mysteries of quantum mechanics, and that is that the quantum, single particle or quantum of energy, is affected equally by events in the past as well as in the future.
Yeah, that's right.
Go ahead.
Okay. So once we came to this point, we can come now to the basic thesis that I believe that we are facing a new revolution in physics.
Oh, yes.
And I want to first talk a little bit about the issue of revolution in general. In the beginning of last century, two revolutions shook the world of science: relativity and quantum mechanics. Both revolutions did not say that classical physics is wrong, because in the whole range where classical physics was checked experimentally, it was completely right. So that means that the only way that a revolution can happen is that we come to a range of phenomena that has a new region that was never tested experimentally before. In the case of relativity, it was moving close to the velocity of light, which nobody was able to do before, and therefore all the experiments that were done in classical physics never could discuss what happens when something moves close to the velocity of light. In the case of quantum mechanics, it's because we found new way to do experiment on extremely small light particles that we discovered this new phenomena that is called quantum mechanics. So now I suggest there is another region of physics where experiments were not done so far on it. And that region is the region of complexity. The system that is most complex in the universe that we know about is our mind, our brain. If you look at the way that the brain is organized for that number of atoms that are in the brain, this chair is extremely simple system, even though it has more atoms than my brain, but they are organized in a trivial way. The way that the brain is constructed is the most complex structure that we know about. Therefore, I suggest that some of the experiments that are our own experience are experiments about the most complex system in the universe that could never be tested otherwise in the laboratories. So if I look at some of my experience that I call experiment on the most complex system in the universe, like the feeling that I feel that I'm free, the feeling that I feel that the time is developing from one present to another, all these experiments on this complex system, the physics of today tells me that this is an illusion. The physics of today tells me that free will must be an illusion, and we will discuss in a minute why. Also, the physics of today tells me that time is a parameter. It doesn't go from one time to another. All times, in a sense, exist together. That is a film in a movie. All the pictures are there, and we can move it so that we see that the system
This
is
was
moving.
Einstein's view, four dimensions, and they're all fixed.
Einstein wrote a letter to the wife of a friend of his that died, and he told her, you don't have to suffer too much, because after all, we know that all the times exist, and therefore the time that you were together with your husband is still there. It will be forever, so don't worry about the fact that right now is not there anymore. But we know, of course, that that one present is more important than another, and there is no way for the quantum today to tell us, for the physics today to tell us what is this meaning. So they say this is just an illusion, that time is really developing from one present to another.
So we have a straitjacket which is already there by relativity theory, special relativity and general relativity. Relativity made time just another dimension, just like space. So what do we know about space? East and west coexist. South and north coexist, up and down. They have the same degree of existence. We used to think that past and future, it's different. The past is fixed, the future is still open. Not so in relativity theory. In relativity theory, they have the same degree of existence, past and future. And when you, Yakir, are doing this gesture, which I described earlier, actually I should tell our viewers that you are applying it not only to particles, you're applying it also to human beings. We are affected, just like the particle, directly, without even thinking about it, without even knowing it. Some part of our brain is somehow affected, of course, by the past, but how we were educated, how we were born, and so on, but also by events in the future. So I understand now that you are actually by allowing the future to affect our present, and then our present again to affect our future, you're going against the relativistic picture. You say that the future is genuinely open, such that freedom of choice is genuinely possible.
Similarly, about free will. Let's talk about free will for a minute.
But allow me just to say something where I'm so much baffled. I can understand your two-state vector formalism when you're talking about a particle, because this is what you have proved in the ABL, Aharonov, Bergman, Leibovitz, back in the 60s, that indeed when you are making two measurements, the particle is affected by both of them. Now you want to tell me that I have a free choice to make, whether I'll be a good man or a bad man, whether I'll commit a crime or not.
Wait, don't tell me what I want to tell you. Let me tell you and then ask your question, okay?
Oh, go ahead. Go ahead. We're talking about free will.
Yeah.
On the one hand, there is a particle, and on the other hand, there is a free will. And how can you bring the two of them?
No,
go ahead.
It's subtle, okay? So let's remember the problem of free will and science. When Newton discovered these new physical laws, then there was an outcry. Hey, you tell us now we are a physical system, our present determines completely our future, and therefore there is no room for any free will. Right? Because anyone that knows our present will be able to tell exactly what we will do in the future, so there is no room for free will. Then came quantum mechanics, and in quantum mechanics, there is suddenly a possibility of saying, look, the past does not determine the future completely. There are probabilities, but we cannot tell what will be the future. Therefore, perhaps there is a room for free will there. So, for example, you take an electron and you send the electron through an experiment that afterwards is called the Stern-Gerlach experiment that depends on the spin of the electron. It will move either to the right or to the left. Mm-hmm. And we find the electron moving to the right. So the electron can tell us, look, I chose to go to the right. In fact, you couldn't predict where I would go. It was my decision to go to the right. But then we tell the electron, hey, we prove to you that you are wrong, because we repeat the experiment again and again many times, and then the electron tries to choose all time to go to the right, and he can't do it because half the time he has to go to the left. Mm-hmm. So therefore, the fact that we cannot predict where it will go at one time doesn't mean that he really has a true free choice to decide where it goes, because there is a constraint of probabilities that tells it that half the time it must go to the left. Therefore, the choice whether it goes to the right or the left is like throwing a coin and not like a real meaningful freedom. So, when I think that there can appear something new in physics that has to do with complexity, I start with the idea that our brain is so complex that there is no way to make a copy of it. No way to take my brain the given time with all my experience and all the things that is there and make a copy that will have exactly the same properties.
You say it's not a problem of technology, but there is the universe or the laws of physics say that this is the limit of replication. This